If you work at a company with developers, there's a good chance that the time will come when you're going to need to know Git. Git is absolutely fundamental. It's like knowing how to use the command line. You can get along without it, but you have so much more power at your fingertips if you invest the time to learn it. So in the next few minutes, I'll give you a concise quick start on Git. I'll teach you exactly what you need to know to add this to your cybersecurity tool belt. Okay, so we're going to start with a short history of source control. We'll build a Git mental model, including the most important commands, and then we'll talk about branching and how it protects the Git repository. And finally, we'll finish up with a fast way to figure out who changed something and why. So let's go ahead and jump in. So to really understand why Git is such an important tool, you need to know how things were done before Git came about. In the early days of coding, source code was stored on stacks of punch cards that had to be stored in sequence. According to the website Computer Hope, the largest punch card program was from the 1950s Sage air defense system, and it was 62,500 punch cards, or the equivalent of about 5 megabytes of data. Now, I didn't ever have to develop in this world, thankfully, but I had professors who did, and they all said the same thing. It seemed to work okay, until your stack of cards tipped over and you lost the sequence of your program. So developers came up with a few tricks. They'd write on the sides of punch card decks with markers, and they'd often draw a thick diagonal line to help keep the stack in sequence. So if it ever got out of sequence, they could tell by looking at the side. And sometimes they'd use markings to designate functions or discrete sections of the code. And as I said before, fortunately, I never had to experience the pain of a mixed up stack of punch cards. My experience started with source code being stored on local file systems or network file shares. If you think of it, an application source code is just a collection of files. So it made sense that you could store source code text files in the same way that you stored other text files. Now that worked okay for a single developer, but as soon as you wanted to collaborate with multiple people, it became a big issue. So picture this with me. So I open a source code file on my laptop and I start making a major change. It takes me several hours. I'm working over multiple lines of source code and I finally finish. But right before I save my changes, Bob in the cubicle next door opens up the same file to add a quick comment, fix a typo. He's working on the same version of the file that I'm working on, but it doesn't have my changes. So I save my work, and then 30 seconds later, Bob hits save on his. Bob's single line change overwrites my hours of work across multiple lines of code. So that's what development life looked like before source code management systems became prevalent. You had lots of issues, lost work, collisions, and a lot of sadness. So what we really needed was a source code management system that could manage file versions and handle concurrent work with multiple people. One of the earliest systems was CVS, or the concurrent version system. And CVS helped enforce a lot of development practices that we know today. It was a big improvement. It was client-server based and it helped track revisions. But there were a few problems. It tracked revisions on a file level. So that made multi-file changes hard. If a large change across multiple files ran into issues with one or more of those files, that commit could be partially applied, which means some commits, some files would be committed and others would not. And the problem with that is that you just introduced a code change that wouldn't work, and you had to go figure out where it failed and why. So next came Subversion, or SVN. Subversion took the approach that changes consisted of the entire source tree. It was an all or nothing approach. So if the commit wasn't entirely consistent, if that commit didn't work fully, it wasn't merged. But the problem with both CVS and Subversion is they struggled with branching. Now, branching is the concept that you can create a branch from the source code that lives in parallel to the main branch. And often this is used to develop a feature or bug fix in parallel. So what happens is you take a snapshot, essentially, of the code, which becomes your branch. You work on it in parallel, and then when you're ready, you merge that back into the main branch. In CVS and Subversion, this was a very painful process. So Git. It was born out of a desire to make a system that was highly distributed. So it was created by Linus Torvalds back in 2005. And he did it because he needed a way to make Linux kernel development highly distributed. So kernel development in Linux has a unique problem. A lot of people contribute very small changes. So he needed a system that was highly distributed. He needed to be efficient and fast, so he created Git. Instead of simply tracking changes to files, Git tracks the state of the whole file system as snapshots. It keeps a log of hashes of those changes to keep a precise history of what changed, when it was changed, and by whom. So let's talk about the mechanics of how Git works a little bit more. So Git uses 3 environments that you should know about. The working directory is where you edit files. This is the directory on your local development machine where your source code lives. The staging environment consists of files you've queued to commit. Think of it kind of like your shopping cart. You've made the changes, but you aren't quite ready to check out or commit to the changes. A commit happens when you bundle up a set of staged changes. Now Git makes a permanent record with commit hash and log entry. You also need to understand that a file can have several states. First of all, a file is either tracked or untracked. A new file won't be tracked until you add it to the staging area. Once a file is tracked, it can have several substates. Modified means that it has been modified since the last commit, and staged means that the changes are staged and ready to be committed. And obviously committed means that the file contents are stored and Git is keeping track of those. Now the purpose of the graphic on screen is to show you how files transition between those different states. So you start off with a new file or change to an existing file in your working directory. You use the git add command to move that file to the staging area, and at that point it's ready to commit. You can use the git commit command to create a commit to the repository that's tracked by Git. The next command is git push. Now git push allows you to push your commit to a remote, and a Git remote is an external server that allows collaboration with other developers. So this could be GitHub, could be GitLab, could be Azure DevOps. There are many different types of Git remotes that allow you to use Git to collaborate with other developers. So let's go ahead and walk through this together. My recommendation is to follow along at home, do this on your machine as I do it. So if you've never used or installed Git, make sure you install it first. I'm not going to do that here. There's plenty of good tutorials online. After you're done installing it, you should be able to check the version by typing git --version, and you should see something similar to this. All right, so I'm starting with a blank directory. The first thing we need to do is initialize the directory, and we do that with the git init command. So you can see the command completes and it tells you that now we've got this .git directory. So this .git directory contains a lot of the information that Git uses to track changes from commit to commit. So let's go ahead and add a file. So first thing, I want to introduce you to the git status command. So if we do that, you can see several important things. First of all, it tells us that we're on the main branch. There have been no commits made yet, and that there's nothing yet to commit. So let's go ahead and create a file. Okay, so now if we check git status again, so now we see that there's a file that is new, that's untracked. So we can track that or add it to the staging environment with the git add command. And again, git status tells us that now that file is tracked and it's staged, and now we can commit it. So let's go ahead and do our first commit. Now there's a couple of ways to do this. Git commit -m will allow you to add the commit message directly on the command line. So let's just say first commit. And that will work just fine. Now if we run git status, we see that there's nothing else to commit. So the other way to do that is by just typing in git commit, and then you can use Vim to type your own commit message. So this would be helpful if you wanted to do something longer than just a simple commit message. So let's go ahead and create another file, and this time we'll add that to the staging environment. But this time we're not going to specify the commit message on the command line. We'll just type in git commit, hit enter, and you can see it asks you to type in your commit message. So this time we'll say second commit, we'll save that, and if I do git status, see that everything is up to date now. Okay, so that's how you would do commits. Now, what if we accidentally delete or change a file? So we've got these two files. Let's say we accidentally delete the first one. One of the nice things about Git is we can actually restore from that. So we can use git restore, just type in git restore, test.txt, and that file comes right back. So awesome. Okay, so what if you actually did want to remove that file, both from the local file system and the Git repository? Git has the git rm or git remove command, and so if I type that in, it will remove it, and you can see that it's removed from the local file system. But now if I check git status, you can see that there's a staged change for the file deletion, but I have to commit that before it removes it from Git. Now if I did that on accident, I can restore that. You can see the command here, git restore staged. So that removes it from the staging directory. So if I run git status now, you can see that what it's telling us is that there's a file that's been deleted that hasn't been committed, but that file still isn't in my local directory. So I can use the git restore command again, and now it's back in place, and I check git status, and there's nothing to commit, so we're back to where we started. Now, another thing is if you actually want to rename that file, there's the git move command. You would type in the name of the file that you want to change, and then the new name, and that will change it locally. And then you'll see that there's also a commit that we need to make. So let's go ahead and do that. And that has been committed now. Okay, so now let's talk about branching. Git uses branches to protect your code. So your repository has a default branch, which is usually called main. Some older repositories name the default branch master. Generally, you should never commit directly to the default or main branch. The idea is that when you want to make a change to the main branch, you create a new branch. You work directly on your new branch, and then when you're ready, you merge that back into main, like this image shows. So in this image, we've got two branches in process. One's for feature work, the other's for bug fix work. You can see they run in parallel, and then eventually you merge those back together when they're ready. Okay, so let's see what that looks like in Git. So when we run git status, it tells us we're on the main branch. Well, how many branches are there actually? So if I run git branch, it tells me that there's only the one branch. And the asterisk to the left of it tells me that that's the one we're working on. So let's go ahead and create a new branch. We're going to type in git branch, and we'll name this bug fix. And if we run git branch again, we see now we have that second branch, but we're still on main. So how do we get to the bug fix branch? Well, we have to check it out. So git checkout bug fix. And then again, if we run git branch, we'll see that now we're actually on the bug fix branch. And git status shows us the same thing. So let's go ahead and add a few files. All right, so we've got 2 additional files in the directory. So how do we actually merge that into main? To do that, we actually have to check out main or switch into main. And once we've done that, we can run the merge command. So git merge bug fix. This is telling Git to take the bug fix branch and merge it into main, or the one that I'm working on. Okay, but you see what happened there? I forgot to commit those files. So I'm going to go back into my bug fix branch, and let's add those files. Okay, now we'll check out main and we'll try the merge again. So the bug fix merge worked this time, and now we've got those files merged with our main branch, and sure enough, git status shows us that we are on branch main, there's nothing to commit, and everything is clean and ready to go. Now what if we want to find out who made a particular change? In that case, git blame is your friend. This quickly answers the questions: who made the change, when was it made, and what was the change? So let's just try it. Git blame new.txt, and you can see here I made it, what the date was, date and timestamp, and what I did there. So that's an important concept. If you're ever in a situation where you're doing an incident response, or you're trying to figure out when and where a change was introduced that either introduced a vulnerability or introduced something nefarious, and you want to find out who did it, git blame is your friend. It's exactly the tool that will help you find out what happened, who did it, and when it happened. All right, so now you have an understanding of Git and how to use it. So I recommend go play around with it and dig in. That's where it's going to really solidify for you as you play around with it, try it on your own machine, and see what it can do. I'll list a few additional resources you can use in the notes. All right, so this is just a small snippet of content from my DevSecOps course. If you like this, I think you'd really like the course itself. We go a lot deeper into things like branching, branch protection, pull requests, and how to use the native features of Git and GitHub to keep your code safe. You can check it out at devsecopspro.com. Hope to see you there someday.